Hi and welcome back for the fourth part of the tutorial for the creation of a card game with battle grid. Today we'll see how to shuffle our deck. Also, before starting, I will give you a quick explanation about FIFO and LIFO. In addition, we'll see how to get a random number. Let's start with our usual program and let's see at what point we left it. Okay, so as you can see, we have our array deck data or information. It does all the sort, so we don't want to see this anymore, so we're going to disable it, the reverse and sort. All this part here we can just disable, we don't need it. We leave all this function at the moment, but we are going to probably use in different way in the future, so I might just get rid about this later on. Before we start our program, I'm going to enable again full hand because we want to show the distribution of the cards, and then again the drag and drop I'm going to disable for the cards, so it should work as the first time. Let's start it. Okay, so our cards are distributed. Now I'm going to explain what's FIFO and LIFO, because with these cards here it's easier to see and explain. FIFO stays for first in, first out. When we put elements in our array, we start from the first one at index 0, then we put our second element at the index 1, and so on, until we go and reach the end of our array. Now that we have all our array completed, we are going to access to it with the FIFO system in order to create the deck. This means that the first element that has been inside is the first element that will go out. So first element of our array is at the index 0 is the first element that goes out. So it's the first element that we're going to work with. So it means that from here I'm going to create the card. The first card will be here with the value 0. Then when I access to the second element, I will create a second card here with the value 2, and so on until I reach the top of the deck and I have the card number 9. So we have all our 10 cards here using the FIFO system. First element in is the first element inside the array is the first element to go out, so the first element to be elaborated. On the other hand, when we use the LIFO, last in, first out, means that when we have our deck here that is full with 10 cards, we take the card that is the number 9, so the card is the last element that has been put inside our array. So in this case, the last element that being used to create our deck, and is the first card that goes out. So the first card that goes out is the last one of the deck. It goes here, is the 9. Then the second one on the from above in our deck is the number 8 and goes here, and so on until we keep taking all the cards from the deck until the end. So this was the difference between FIFO and LIFO. So why I am explaining this to you now? So I'm teaching these things because when you're going to work or talk to other developers or even game designer, you need to be really careful to understand in which way you need to manipulate the array or access to the array. So someone can tell you, okay, we access to this array using the FIFO, or rather we use the LIFO, and that's make a big whole difference. Okay, close this introduction. We can go back to our program. On our event sheet board, we are going to just close all these, make a little bit space. This one, as I said, we can leave it for now, and we call a new function. Actually, we create a new function that we call it shuffle deck. Okay. Now here I'm going to explain you something a little bit unusual than before. If you remember, I explained in the past about the global variables and also the instance variable. Now we use the local variable. Local variables are variables that are only working inside a certain sub-event. They are not accessible from other part of the code. So when I create a sub-event here and add a new local variable, this variable here will be accessible only in this part of the code. It will be automatically reset during every tick of the game. So this is good because sometimes we need to have some variable just as a support to make a quick calculation, to stay data just briefly. And we don't want to keep having a long list of variables in the global variable because it becomes so long and so annoying to find a variable name when you have a lot of variables in the program. For make it easier to read the variable in our events when we're going to pick a name. It's also good because we free the memory of the computer. We don't need to store data that we don't use for a long time. Okay, so we're going to create two new variables, and one is called support index. Both the variables are numeric variables, and the next one is just rename this one support value. Now, just as a quick demonstration, if I go here on system and then set value, I don't have any variable because I don't have any global variable yet on the game. But if I'm going to put this up, they become global because they're not inside the sub event, as I said before. And when I go to create set a value for a variable, now I have the option to see both of them. So that's what I meant before. This was just a demonstration. I bring them back inside so they become local and they work only in this point here of our code. Now let's go back to see our screen here to explain why we need those local variables. So we need to shuffle our deck. There are, as usual, many ways to do it, like for example using a second array and so on. I personally prefer to use only one array and use only two support variables, the one that I created before. This is because we can save a resource for the computer. We don't need to do many complicated things. So what are we going to do? In a theory, we take each element of the deck and we shuffle. So we are going to make a loop to say that each card is going to move. It's going to move in any place from 0 to 9. Because if I move this element is on 0, this card, and I shuffle the card, it might happen that also it goes back to the first point, because you never know. So we need to take any elements randomly. So when we are doing the shuffling, we use a loop. And inside the loop, we go from first element to the last, and we pick one random point where we want to put our card that is element number 0. So let's say that the new point where the card has to move from 0 goes to 5. If I'm going to overwrite the information, so this 0 I'm going to write it here on the position 5, I'm going to lose this 5 here. And I can't put this 5 anymore back here because the computer doesn't know the value that was there before. So that's why I need the support index and support value. With support index, I just use it to define where I'm going to put the new value. So like in this case, index x at 5. A support value will be the value that there is at this position. That is in this case 5. As usual, we use a number when we define the game, what we want to have in the game. We can have anything, it can be robots, spaceship, monster, or whatever. Now it's just number. It happened that this number is the same on the index and the same of the value. Don't confuse. Later on we make something different. By the way, at the end of the video I will talk about poll that we can do together, so you can vote and decide which is the theme of the game we are going to create with these cards. Okay, let's go back here. I open here a notepad file, so it's easy to understand. So loop index and support index equals support value. Okay. When we start our loop from 0 to 9, the first value of the loop is 0. So we write here loop index. Then we get a random value where we want to move the card that is here. And as say before, the function we're going to create will take this 5 as an example, as an index, this 5 here, sorry. So we write in support index 5. Then we're going to copy the value that is at the index 5, that is 5, the value, and we write inside support value. Now, from this moment, I'm not going to lose these two values anymore because they're stored in a local variable. So what I'm going to do now, that is this 0 that is here, I can write on the slot number 5. So on the slot number 5 now there will be the card number 0. And how do I know what to put here? I know because I use the support value as a variable, and then I use this variable to put the data here. So this 5 that is here will go in here. So now we'll have the 5 here and the 0 here. So that's why I need support value. Of course, support index is required to know where I'm going to point when I picked up the card first and then to replace. So that's why we need these two local variables. So I can close this one, we don't need to save. And then another thing, when the loop, now I already closed the window, when the loop index becomes 1, so we are going to start to do the same thing from this point. So it will be the 1 that will be put in any place from here to here. And let's say it will be a number 7. So now number 1 will be here. The 7 is saved on our support variable. And then we put the 7 here to replace the number 1. And so on. And we keep going until we reach the end of our array. And then all the deck will be shuffled. So that's how it works. It's quite easy thing. So it will be ready in a few minutes. It takes more time to explain rather than actually doing it. Okay, from now on we can work at our function shuffle deck. And how we access to this array to shuffle the cards? Was it FIFO or LIFO? Do you remember it? It was FIFO. First in, first out. The first element of the array will be the first one to be moved. So let's create a 4 here. And as I said in the previous video, I prefer to use this normal 4 because it gives us more control compared to the for each element of the array condition. This because I might have some special things in the game that let me check only some part or shuffle some part of the array. So for example, I have a card that say have a look at the first 3 cards on top of your array, then shuffle those 3 cards. So if I use the 4 that is inside the array condition, I don't have the control to check to loop only 3 cards. That's why I'm using this normal 4. So start the loop at 0 because the first index of the array is 0, and then the last element I could write 9, but I don't know what's going to happen to this array. It might increase the number of cards in the deck or become less. So I'm going to write array deck dot width. Now keep in mind, as I said the last time, the array width is actually 10 elements. So if you loop in this way, it will loop 11 elements. 0 to 10 are 11 elements. So you need to do array deck with -1 to make sure that you loop within 10 elements. You don't get strange results. Done. The next step is to find a way how to get a random value where we want to move our card. So first thing, we go to System, set value of support index, that is the index that says where we're going to put the first card, or maybe the card that is actually the loop pointing at. In this case, we start at 0, will be the first card. And we need to see how the random function works, random code. So we click random, or type, and then random goes with two range. 0 is the minimum value you can get, then comma, and you write the maximum value you can get. In this case, array deck dot with, and I close it. Now, two things I need to explain about this random function. First one is that, as I said before here, array deck is 10 elements, so the width actually give us 10 as a value. But I'm not going to do -1 in the random expression, because the random value never get this maximum value as a result. It can get anything from 0 to this one, but not up to this one. So let's give an example with numbers. 0 to 9, sorry, 0 to 10 in this case. I will never get 10 as a result. I get 0 to 9. Now, the second problem is that the random function gives us not integer value, but float. So value is like dot, so like 3.94731. So it's not really what we want. To avoid this, we need to round the number. As you know from what you studied at school, or you study now if you are pretty young, is that you can have 3 different kind of rounding with the numbers. You can round down, you can round up, and you can just make the closer round. I'm not going to explain, you know already. So we have floor. There is the expression to round down. I use this round down because any value that is between 0 to 0.99999 infinitive will be still 0. And same thing when any value that is 9.0 to 9.99999 and so on still will be 9. We round in this way so each number has the same chances to be picked. This is because if I round in a different way, like with the normal round, I could get the number 0.500001 or above, that becomes 1, and anything under 1.5 until 1, that becomes 1 as well. So if 50% here and 50% there of chance, they make a whole chance to get 1 as a result. But I don't have the same chances to get 0. That is just from 0 to 0.5, let's say. So 0 to 0.5 give me 0, I have a chance. 0.5 or above until 1.5 gives me 1. So I have whole number as a chance. That's why. Sorry for this little side note. Perhaps I should have done a separate video just about this random thing and the roundings. And I hope it's all clear now. But if you want me to have more explanation, I can make a separate video so I can give you more information about this. Okay, so this is done. Now we have this value in our support index. now that we are pointing at the support index, so we are pointing at the specific point of the array, we need to save the value that is in that point. That's why now we use support value. And a support value, we give the value of array deck at which point. In our first example we did before, the first random number was 5. In this case, who is giving us the value that is being taken is support index. Not the value, but the point where we're going to get the value. So the array at this point, support index, will give the value and we store it in support value. Okay, now next step is to going to change the things actually in the array. So we go in the array, set at x, because it's only one-dimensional array, it's not two-dimensional, three-dimensional. Okay, what is the x? Where we want to point in the array to do the changing. So we point on the support index. That's the element number 5 in our example, but of course this will be random every time, and we give a value that is at array deck dot at loop index. So at the position number 5, this is the position number 5, we're going to put the value that is at the position number 0, at the first beginning of the loop. Of course, it will be always different now, just to get with the example we did before. Then on the array, after we move one of these cards, we need to put the other card back inside the deck. So set at loop index. So now we have the first card has been moved in the fifth element. Now what we're going to put in the first element, the first slot. First slot I know because we get from loop index, and we give a support value. Okay, this example using the value we gave before, but in the loop will be always different. So the loop will be from 0 to 9 in our case. Support index, we give at the beginning one random value and we store it aside in this local variable. At that index we use to retrieve the value in the array that is based on the support index, and then we have saved both index and value here. Now we're going to use the value of the first element or the loop element we're looping, and we put inside at the support index point, and what we save we put at the point of the loop. You know, I'm explaining over and over, but I think it's quite clear. But just in case, if you have any question, as usual, leave it in the comment. I'm happy to reply, explain better. Okay, and this is finished. That's all our mixing thing. So long talk until now, it's just this function here. Of course, now you want to see the result, because this is happening only in the array, so it's inside the computer, nothing we can really see. So we need to have some visual feedback, and we want to see this card actually really shuffle in our example. At this point, after the loop, but still not inside the loop, I make another sub event, and we're going to recycle our function. That's why I told you in the previous video functions are good, because we can use them many times. So if you remember, we just reset the visual text here, writing array deck data on top, so everything is cancelled, all the values before, and then we get the new composition of the array after the shuffling. To do this, we need to go here and then call the function shuffle deck, and let's have a look if we did well. Okay, wait 2 seconds. Okay, so we have all the elements are being mixed up. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They are not duplicated. All numbers are there. It means that we did well. Of course, cards here are not mixed yet because we haven't done the visual part yet. This is still like a feedback from to check what is the real content of the array. And if I refresh, I will get different result here. Now it's 9, 2, 1, 3, and so on. And let's wait. As you can see now, it's 5, 3, 7, 1, and so on. Different order. Each number is here. Nothing's been lost. So it works quite fine. So we need just to go back to our construct here. And how do we see the movement in the cards? Because this, as I said before, is just something happening in the array itself, but cards are still in the same order. So we need to go to change this visual part. Inside the create deck, we have the loop here, if you remember, to set the animation of the cards after them be spawned, and the position on the Y to create to stack the cards in the deck, and set the value in the array. So we're going to duplicate this block here, and I get rid about all this, and as the first thing I want to put the values in the array, because the array is empty at the beginning of the game. As usual, will be filled with values from 0 to 9, because at the moment we haven't defined yet what's the theme of the card. And then after, go to create another sub event that will place between these two loops here, and I'm going to drag this shuffle deck inside here. So what's happening here? First, at the start of the layout, I create a deck. I put the values from 0 to 9 in order. After that, those values are in the array. I'm going to shuffle the deck. Another thing I want to do, just get rid of all this call to function and things that we don't need, to make it a little bit clear, because it starts to be a little bit longer, our code. It's easier to find things. Now, going back at this second loop here, I'm going to duplicate this action here. So I'm not going to animate anymore the frame, just to set the animation frame using the loop index as we did before. If you remember, the cards are in order from the frame 0 to 9 with the images that is actually written 0 to 9 as a number. This for now. But I'm going to set the animation based on the value that is in the array, because otherwise our card will be in order 0 to 9, but I want that they follow the order that is mixed in the array. So it will be array deck at loop index. So basically, inside this loop, from the first element, it go to check whether there is element number 0, and say which animation should I put as a frame for the card, which value is inside the loop index 0. Let's go here. In this case, it's number 5. When the loop will be, so I will have a card with image number 5 as a first card. And then as a second card, I will have a card number 3, third card number 7, and so on. Because I'm following the loop, and the loop is checking what there is inside at that point. So this one is disabled. This is the Y, nothing to do. This one we're going to disable as well. I can just delete it, but I will disable just so that you see what's happening. Show array here, I'm going to disable it as well, because it's called already inside the shuffle deck. So we have a create deck that is here, that calls shuffle deck that is here, it calls show array. So I don't need to do anything because one inside each other. So otherwise I get duplicated thing and I get mistakes or bad visual effect. So that's it. We can go to try. As you can see now, everything works fine, and this is because the first element of the array, first in, first out, 0, was 6. And the 6 will be the first card to put at the base of our deck. The second card will be number 2. Third card will be number 4. Then we have number 1. Then number 7, that is here. Now, why we have this strange order here? Because if you remember, after we have all the cards here, the one on top was the number 3. And we use the LIFO to get last in, first out. Last card inside the array, slot number 9 was the card number 3, is the first to go out. And first slot, number 3. Then the second last card was on the slot 8 was 9, it goes here. And then here we have the 5 as here, 8 and 0. And that's it. So just to show that everything works fine. And then I pick a card from the deck. Under the 7 I will find 1. As you can see. And then after I will find 4, 2 and 6. 4, 2 and 6, and that's it. So this is the end of this visual feedback. I want to just take a little bit of few minutes from you because I want to talk about this poll we are going to do. But before this, if you enjoy this video, please click on like, share with your friends, subscribe if you are not subscribed yet. You can hit the bell to get notification for the next videos. And if you really are happy to what I'm doing for you, please share these tutorials I'm doing amongst your friends or other people that you think might be interested in, because you really help me a lot. The more you help me to share the videos, the more time I have to actually create new videos, and then I use less time to share them around. So it's just helping each other. Okay, now what's about our poll? I have created a poll on my Patreon page. You can go there and you can check all the suggestions I've created that you can choose for create our card game. So it can be like fantasy monsters or robots or anything that I just brought it there, or that you can suggest, because I just put some elements for our theme that came in my mind. But of course I'm glad to read your suggestion if you have any. You can vote there. You just need to register to Patreon if you are not registered yet. It doesn't require you to subscribe or to pay anything just to vote, but you need to be registered, otherwise you can't vote. And after we have defined the genre, we can create together with this card. I can make the drawing by myself if I'm skilled enough, let's see, or I might work together with some of you if you are interested in some sort of a collaboration. We can talk about that. And I think it's quite interesting to have a game that's actually a proper theme, and also because this will let me to define the next video and the next rule to apply to the game itself, because it's not really everything defined until the end. I have just a general idea what I'm going to do in the next videos, but without the theme, a little bit tricky. That's why I want to have something ready. The poll will be open until the end of this month. That is 30 September 2020. And then another thing I want to talk about is that in the next video we are going to do many other things. Just not saying in order now, but just telling you what's about. Will be like adding the stats of our units in another separate array. Keep track about the units or cards anyway that are going to move in our tile map, making them fight, and how to get this statistic or anything that we want to see from the bot. So really many information still they need to do. Yeah, a lot to study, but I think it's a quite interesting game that can come outside, and it's a different tutorial from the usual platform that you can see around. So I hope you enjoyed this. Thank you for being with me all this time again. I'll see you next time. Bye.